Okay, today's video is going to be about absolute value equations. Our learning target is just to be able to solve absolute value equations. And this is what your worksheet looks like. The video is going to talk about these notes up here. You're going to want to make sure to watch at least that much of the video. And then I'm going to walk you through all the odd numbers, just like we have been. You do have to have all the odd numbers completed whenever you turn this in. So make sure that you pay attention to... You can ignore this over here. I forgot to delete that out of the slides. But make sure that you either do these on your own and check your answers, or watch the whole video and get all the notes. Let's go ahead and start right in. So first we want to recall what absolute value even means. And absolute value is the distance from zero. So the absolute value, if the absolute value of x equals 7, what are the possible values of x? So if a number on a number line, we have 0, and it's 7 units away from 0, that can be positive 7 units, or it can be negative 7 units away. So x could equal 7 or negative 7. And this can also be written as x equals plus or minus 7. Then it asks us if the absolute value of x equals negative 4, what are the possible values of x? The problem with this question is that this is a negative. You can't have negative distance, because even if I am, 3 feet behind the finish line on a track, I wouldn't say I'm negative 3 feet from the finish line. I'm still 3 feet from the finish line. Whether I'm in front of it, behind it, to the side of it, doesn't matter. Okay, so you can never have absolute value equal to a negative. Now, keep in mind, x can equal a negative number, but the absolute value of x cannot equal a negative number. I hope that makes sense. So there is no solution to number 2. And I've listed the steps here that we're going to use to solve absolute value equations, but instead of going into them here, I'm just going to go into an example and we'll look at that. Just kidding, I forgot about something. So this last step, once we solve both equations, we then have to check for extraneous solutions. So what in the world is an extraneous solution? Extraneous solutions are solutions that can be found algebraically, but do not work in the original function. Okay, so when you solve for x, you might get an answer that whenever you plug it back into the original equation and try to solve, it doesn't work. That's possible. So those are called extraneous solutions. Let's go ahead and jump into some examples, and at some point we will see an extraneous solution and you'll understand a little bit better what that means. For number 3, we have the absolute value of x minus 9 equals 5. So step number 1 tells us to isolate the absolute value expression. So the absolute value expression is everything between these absolute value symbols, and we want to get it by itself on one side of the equal sign. That is already the case here, so we don't have to do anything for that step here. Now we're going to create 2 cases. Set the inside of the absolute value expression equal to both the positive and the negative value of the number on the opposite side of the equal sign. So here's what that looks like. We're going to rewrite the equation without the absolute value sign, and then we're going to rewrite it again, and it's going to be equal to negative 5. So here we have the inside of the equation, and here we have a positive 5 and a negative 5. And now we're going to solve. So we've created 2 cases. Now we're going to solve both equations. So add 9 to both sides, and we get x equals 14. And here we add 9 to both sides, and we get x equals 4. So we have solved both equations. But now is when we have to check for extraneous solutions. We have to make sure that these values of x actually work in our original equation. So the absolute value of x minus 9 equals 5. First, we're going to plug in 14. 14 minus 9 is 5. The absolute value of 5 does equal 5. So that one works, and that is one of our solutions. Now we have the absolute value of 4 minus 9. That 4 minus 9 is negative 5, and the absolute value of negative 5 does equal 5. So these are both solutions. You always have to check for extraneous solutions. Number 5, remember first we have to isolate the absolute value expression. So we want to get it by itself. So we need to get rid of this 17. So we need to subtract 17 from both sides. That's going to leave us with the absolute value of y minus 1 equals 5. Then we create two cases. We want y minus 1 equals positive 5 and y minus 1 equals negative 5. Then we're going to solve both. We're going to get y equals 6, and we're going to get y equals negative 4. Then we're going to plug these back in, and you can use this version of the equation or this version. This one's more simple, so that's where I'm going to use it, but you have to use a version that still has absolute value bars. You can't use this one and you can't use this one. So the absolute value of 6 minus 1 has to equal 5. That means the absolute value of 5 has to equal 5, and it does. Then we have, so 6 is a valid answer. The absolute value of negative 4 minus 1 equals 5. So this is the absolute value of negative 5 equals 5. That is true, so this does work. Okay. Number 7, we want to isolate the absolute value expression. It is getting multiplied by 16. The opposite of that is to divide both sides by 16. So that makes these guys cancel, leaves us with the absolute value of r minus 5 equals negative 2. So we have r minus 5 equals negative 2, and then r minus 5 equals, and this one started out as a negative, so we need to also do positive 2. Then solve both equations. So r is going to equal positive 3, and r is going to equal positive 7. Then we go back and plug it in to this equation. So my first one I'm going to test is 3. 3 minus 5 is negative 2. Okay, so I just realized something that I should have realized long ago. At this step right here, we have an absolute value equal to a negative number. Right there, I should have known there was no solution. But I wasn't paying attention, so I went ahead and solved it out, and I got to here, and I realized that the absolute value of negative 2 is positive 2, not 2. And the same thing is going to happen when I check this. We're going to get 7 minus 5, and we're going to say the absolute value of 2 equals negative 2. That's also not true. There is no solution to this problem. And you could have stopped here and not had to do any of this. Number 9. Let's see here. So we want to get the absolute value alone. We're going to add 11 to both sides. That gives us 6 equals the absolute value of 8 minus p. Then we said we'll have the positive and negative versions of this. So we're going to have positive 6 equals 8 minus p, and negative 6 equals 8 minus p. And then solve for both. So subtract 8, we get negative 2 equals negative p, divide by negative 1, and we get positive 2 equals p. Here we'll subtract 8 again, we'll get negative 14 equals negative p, and divide by negative 1, we get 14 equals p. Then we're going to plug both of those into this more simple version. So we have 6 equals absolute value of 8 minus 2. 6 equals absolute value of 6. That is true. So p equals 2 is one of our answers. Then we have 6 equals absolute value of 4. Oh, just kidding. I plugged it in the wrong spot. 8 minus 14. 6 equals absolute value of negative 6. That is true. So this is also an answer. Okay, let's try another one. We want to get the absolute value part alone. So we're going to subtract 9 from both sides. negative 4 times absolute value c plus 10 equals negative 24. Then we need to divide both sides by negative 4. Those will go away. Sorry, I forgot to mark those out. Absolute value of c plus 10 equals positive 6. So then we create two cases. C plus 10 equals 6. C plus 10 equals negative 6. Okay, so you guys should laugh at me because I paused the recording and did all of number 11 without actually recording it. So I'm going to do it again. So in this one, we're going to subtract 9 from both sides. That leaves us with negative 4. Absolute value of c plus 10 equals negative 24. Divide both sides by negative 4 to get absolute value of c plus 10 equals positive 6. Then create two cases. So c plus 10 equals 6 and c plus 10 equals negative 6. Subtract 10 from both sides. I didn't mean to do both equations at once, but it's going to happen that way anyway. And the 10s cancel, and we get c equals negative 4. And over here we get c equals negative 16. Then we're going to plug those in to our most simple version of our absolute value equation and see if they work. So we have the absolute value of negative 4 plus 10 equals 6. This says the absolute value of 6 equals 6. That's true, so c equals negative 4 is an answer. Next, we have the absolute value of negative 16 plus 10 equals 6. This gives us absolute value of negative 6 equals 6. This is true, so c can also equal negative 16. Okay, we have two more problems. This one is already isolated, so that part's done for us. So let's go ahead and create two cases. So we're going to have one case that's exactly how it is, and then the other case is the negative version, but this one has variables over there. So we have to have negative x plus 1. The whole right side has to be negative. So what we're going to end up doing is distributing this like a negative 1. And we'll get to that in a minute. We're going to start with the positive version. So subtract x from both sides, and we get 2x minus 9 equals 1. Add 9. 2x equals 10. And then divide by 2 to get x equals 5. So that's one possible answer. Then we are going to have 3x minus 9 equals negative 1 times x is negative x, and negative 1 times positive 1 is negative 1. So then bring your variables to one side. So we get 4x minus 9 equals negative 1. Add 9 to both sides. 4x equals 8. Divide both sides by 4 and get x equals 2. So now we have to test both of our answers to see if they work. So this is the only version of the equation we have, so that's what we're going to use. Our first option to test is x equals 5. So we'll have absolute value of 3 times 5 minus 9 equals 5 plus 1. So 3 times 5 is 15, minus 9 is positive 6. 5 plus 1 is 6. The absolute value of 6 does equal 6, so 5 is a possible answer. Now we're going to plug in 2. The absolute value of 3 times 2 minus 9 equals 5 plus 1. Not 5 plus 1, I'm sorry. That's x plus 1, so the x in this case is 2. So 2 plus 1. There we go. So absolute value, 3 times 2 is 6. 6 minus 9 is negative 3. Equals 2 plus 1 is 3. So the absolute value of negative 3 does equal 3. So x equals 2 is also an answer. And here's our final problem. I'll go ahead and tell you this one will have an extraneous solution. So you're going to understand a little better what those mean after we look at this problem. So first we want to get our variables on one side. So add 5 in to both sides. I didn't mean variables on one side. I meant we need to get our absolute value isolated. So this equals 6n plus 2. Okay, so we have our absolute value expression isolated. Now we need to create two cases. So 8 minus 2n equals 6n plus 2, and 8 minus 2n equals negative 6n plus 2. So on the left side, we're going to subtract 6n from both sides. That gives us 8 minus 8n equals 2. And then subtract 8 from both sides. Negative 8n equals negative 6. And then divide both sides by negative 8. And n equals positive 3/4. Okay, for the right side, we're going to distribute this like a negative 1. So we'll get 8 minus 2n equals negative 6n minus 2. Then we want to move our variables to one side. 8 plus 4n equals negative 2. Subtract 8 from both sides. 4n equals negative 10. And divide both sides by 4 to get x equals, that's an n, not an x, n equals negative 5/2. So these are the two numbers that we need to test. Let's look at this version of our formula. So we have, I'm going to rewrite it over here. 8 minus 2n equals 6n plus 2. And we need to test n equals 3/4 and n equals negative 5/2. Okay, so absolute value of 8 minus 2 times 3/4 equals 6 times 3/4 plus 2. So absolute value of 8, 2 times 3/4 is going to equal 3/2. And then 6 times 3/4 equals 9/2. Sorry, it's distracting in here. So this gives us the absolute value of 6.5 equals 6.5. That is true. So n equals 3/4 is one of our answers. So now we have absolute value of 8 minus 2 times negative 5/2 equals 6 times negative 5/2 plus 2. So this is going to give us absolute value of 8 plus 5 equals negative 15 plus 2. So this says absolute value of 13 equals negative 13. Remember, an absolute value can never equal a negative. This is not true, so this n equals negative 5/2 is an extraneous solution. And if you are checking your answers tomorrow on the even numbers, the way that this answer will look on the answer key is it might say number 15. The answer is n equals 3/4, and it will have an asterisk beside of it. And what that means is you should have found another answer, but it was extraneous, so you don't have to include the answer in your solution. You do still have to solve for it, though, and show all of this work. So like if you were doing number 15, you would have to have all of this work shown to get credit. Okay, hope that helps, and hope you guys have a great day.